Yes, I know. I am very happy to be speaking today with my good friend Avi Loeb, who's a professor, a renowned scientist, the director of the Galileo Project, the founder of the Galileo Project, really the driving force, I would say, behind so much interest nowadays in the phenomena of extraterrestrial entities, whether they be craft or perhaps searching for hard data, not just speculation, not just cell phone camera reports, not just professional skeptics. This is what people want. They want hard data. They want access to the best. And for better or for worse, Avi, Harvard is the gold standard, right? I mean, come on. Harvard is taken as the gold standard. And you were the chair of the department for over a decade. You've been made renowned contributions to areas of theoretical physics, of cosmology, of astronomy, and now pivoting in later stage of your career to things that are exploding in interest among the general public who pay our tax, our salary. I pay my own taxes. I almost slipped and said the public pays for it. Anyway, I'm not feeling good today. I've got it cold, but I wouldn't miss this conversation for the world. We're talking with Avi Loeb, and Avi, welcome. Good morning.
Thanks for having me. It's a great pleasure to join you. And I should say that when I do my work as a scientist, the fact that I belong to Harvard is irrelevant as much as it is for a soccer player playing for Real Madrid. The other thing I would say is that when I'm using instruments to figure out what nature is, that's just like using video cameras in the World Cup in soccer. That's what FIFA is doing. It's not relying on the players to tell them whether there was a penalty or not. It's using video cameras and analyzing them. So, I don't want to use humans as scientific detectors. I don't want to subscribe to social media and listen to how many likes I have.
Well, it's great that you do what you do. And what we're talking about today, and it really speaks about your integrity as a scientist, which is that you routinely get criticized, and you get criticized by lay people, by the media, by people that are that want to see you fail almost, but you never really shy away. You've done more podcasts than I have, and and it's really quite incredible that you have a knack for both the integrity to face challenges, but also the data to back it up. And what you're doing is to never shy away. So the most recent claim, which is met with, I would say, it's almost met with glee. Whenever there's a chance, it's very bizarre, Avi, that people want Oumuamua to go away. They want it to be some comet, some iceberg, and maybe, I mean, we have to say, maybe it could be, but there's a paper published in Nature recently, and it's not the first paper, and it's not even a theory you haven't encountered before. So I wonder if we could explore these papers, and I don't know, do you want me to show the Nature paper first, to show the Nature paper itself that was written?
Go ahead
Okay.
and show it. It appeared on Thursday.
Yeah, so
Yes.
when did you first hear about this paper, Albie?
Well, a dozen reporters from around the world asked for my opinion. The editor of Nature never asked me to referee this paper.
Mm.
Okay. And so I got a copy of it while flying back from Switzerland. I was featured in the World Minds forum there. I had dinner with the former head of NATO, with the most important architect in the world, uh, Lord Foster, and with a number of very important people. And then on the flight back, I got an email from a reporter saying there is this paper that is about to appear in Nature. So that's the first time I noticed it. And then, I was asked by others, and we can talk about the details.
Okay, so good. So let me call up I only have access at home to so many
Yeah.
things in the Nature
By the
archive.
way, just a footnote on what you said in terms of criticism. When I came back from Switzerland, I also found in the mail the following document that was sent to me, a package from
Hold on.
Rome in Italy. And it's actually a collection of all the legal documents against Galileo Galilei that was put together by the Inquisition. And this collection is actually dated 1907, and someone in Rome decided to send it to me. So what I'm saying is this social phenomena of wishful thinking, wanting reality to be one thing while the evidence goes another way, is not new. What is new is that it keeps persisting without us learning lessons from the past. The point is, we should adhere to evidence. We should use the laws of physics as we know them in order to figure out what's going out there, rather than use wishful thinking. And let me just close with two brief examples. I was once at a thesis exam of a physics student at Harvard, and the whole purpose of the thesis was to test the popular cosmological model of cold dark matter based on the clustering of galaxies. That was the purpose, to build up a test. And then I asked the student, what will happen if we apply your test to future data? And it disagrees with the data. And the answer was, then it means that I must have missed something in my modeling, because it should agree with lambda, with the standard cosmological model of cold dark matter. So this is one example. And then the second one was a talk that was given, a colloquium that was given at the Black Hole Initiative when I was the director there, by a very prominent scientist who said that here is the prediction of the swampland landscape of string theory, okay, for cosmology. And I said, that's great that you're making predictions. So what will happen if in the future we have data from the cosmic microwave background that disagrees with your predictions? Would that rule out string theory? And the answer was, no, it will just show that my conjecture about the swampland is incorrect. String theory must be right. Wow. And I say, what have we learned over 4 centuries from the trial of Galileo? Back then, people were 100% sure that the sun moves around the earth, and they were willing to prosecute Galileo for that. And what we learned from that is that debate about the interpretation of reality is the right way to proceed, because eventually the truth will be revealed. Now we can look at the earth from a distance and see that it moves around the sun. So obviously nobody would subscribe to the camp of the prosecutors of Galileo, yet they were 100% sure that they're right, and they put him in house arrest.
Yeah, and I often think that we get so tied up with, kind of accepting the science. People say, oh, scientists say this. So if one scientist says one thing and another scientist says another thing, the public is kind of left in an ambiguous superposition of, like, scientists don't know what they're talking about, which is very dangerous to society, or scientists, they make their whole living off of petty squabbles, which,
Well, when the data is incomplete, sometimes you can't decide, okay, which side to agree with. But if someone says 2 + 2 is 5, right? We all know that's wrong.
Well, Avi, hold on. At your university, there is a gentleman, I think his name is Kareem Carr, and he has many references to 2 + 2 could equal 5. He's actually a math graduate student at Harvard, so we should be careful, because people do accept that, and it's considered almost a sign of, actually, it's claimed to be white supremacy to believe 2 + 2 equals 4. So let's not get into that. I don't want to get into culture wars, but let's avoid 2 + 2, especially at Harvard. And I'd love to talk to Kareem someday, by the way.
The point I want to make is that the use of logic and the laws of physics is recognized as the scientific method, okay? And you can show that the calculation is wrong in theoretical physics. If someone, for example, writes the energy equation, energy should be conserved. All atoms in the universe satisfy energy conservation. It's unlike interactions between people. Human relationships do not obey any universal laws. And we know that because there are societal laws, and the court system, the legal court system, is full of cases where people violated societal laws. So if you decide, and psychologists know that, if you decide that humans will behave in one way, some of them will try to violate that. So we know from human relationships that laws are not universal, but for atoms, all atoms need to satisfy energy conservation. So if this paper in Nature that we will talk about does not satisfy energy conservation, I can show that it's wrong. And there is no doubt about it, because any astronomer, any physicist will agree with me. Mm-hmm. So this is not a matter of debate. Whether energy conservation was satisfied in the Nature paper or not is not a question of opinion. You can look at the equation and see, just like suppose you get a salary and you're saying, can I support my family with this salary? And all you put into the calculation is the rent and the heating expenses, electricity expenses, and so forth, but you forget to include feeding your family. Then obviously you will not be able to sustain your lifestyle because you forgot about a term. And the same is true about energy conservation. If you're
Yeah.
missing a term, and we will talk about which term was missed, then the reality of the situation is that your calculation was wrong. There is no doubt about it. It's not a matter of opinion.
So this paper, I'm going to show it on the screen now. I don't know if you have a copy of the abstract. All I can show is the abstract because.
Go ahead. That's okay.
So it's called acceleration of 1I Oumuamua from radiolytically produced hydrogen, molecular hydrogen in water ice. So let's go through it. If you have it there, you could take us through all these different terms, and I think it's instructive for my audience, which is the brightest in the whole universe, as you know. This audience is incredibly technically proficient, so we can go as deep and nerdy. We did an hour and a half with Martin Bauer this week on the Stern-Gerlach experiment,
Okay.
Avi. So don't be afraid to go deep. Okay, please.
No, it's really straightforward here because we're talking about things that are very intuitive. So the
Yes.
idea of this paper is really simple. We know that comets are often covered with water ice. And so what this paper asserts is that you start with an iceberg made of water, which we know is common in the outer parts of planetary systems like the solar system, and it's exposed to cosmic rays in interstellar space. As it travels to us from another planetary system, cosmic rays keep hitting it, and what they do is dissociate water, which is two hydrogen atoms bound to an oxygen. They basically separate the hydrogen from the oxygen. When a cosmic ray goes through matter, it releases enough energy to break the molecules of water into hydrogen and oxygen. And they claim breaking a third of all water molecules into hydrogen and oxygen is very reasonable. And then they go through the calculation and show that if a third of the iceberg is made of hydrogen, and then this object passes near the sun, when it's roughly at the distance of the Earth from the sun, the hydrogen would evaporate from it and give it the push that is needed to explain the observed acceleration beyond the sun's gravity. That the
That's called
object.
outgassing. That's the outgassing.
Yeah, so usually for comets, and that's the way if you open the Encyclopedia Britannica, a comet is defined as having a coma of gas and dust, and that is produced as a result of the warming by sunlight. If there is water ice, it goes straight from solid into gas, and together with it, some dust is released, and you end up with a coma. And that is very visible because the dust and the gas often scatter sunlight. So you see this huge tail surrounding, and coma and tails surrounding the comet. That's what distinguishes a comet from an asteroid. An asteroid doesn't have that ice, and you don't get evaporation. It's just a rock. And so that's the definition. But here they say, well, we suggest that, in fact, if you take water ice and expose it to cosmic ray, you end up with a dark comet, which in a way is an oxymoron because we've never seen a dark. I mean, the way that a comet is defined is by having a coma around it. And here they say, okay, well, there is a comet. This is Oumuamua, the first object that came from interstellar space. It is a comet, but what evaporates from it is hydrogen, which is transparent. And to calculate how much hydrogen comes out, they calculate the surface temperature of this ice to demonstrate that you can get evaporation. And they calculate the temperature of the surface of this iceberg just the way you calculate the temperature of Mars. You know, basically, there is a balance between the heat delivered to the surface from sunlight and the heat radiated away from the surface when it's at a given temperature. And when you balance the two, you end up with the temperature. And the temperature is just dependent on distance from the sun, and there is a little bit of energy reflected back to space that is called albedo. And other than that, energy in equals energy out in radiation, and you end up with a temperature. So you end up that the Earth has a temperature just around the freezing temperature of water, and we have a little bit of a greenhouse effect on Earth, and that's why it's habitable. And the same is true about Mars. So that's the kind of temperature that you can get on a rock.
Now,
But
the
when you
albedo of this, so I recall, somewhere that the moon has an albedo of like 8% or something, meaning that it reflects 8% of the photons. Is that
Yeah,
about right? Okay.
that's a reasonable choice, 6% typically for asteroids. The point of the matter is they calculate a surface temperature when Oumuamua was observed of about 100, 150 degrees Kelvin above absolute zero by balancing heating by sunlight with radiation away from the surface. That's it. That's the paper.
So
And
one more thing to just summarize, just for my benefit, Avi. The notion that what's happening is there's hydrogen obviously in water, so it's getting irradiated by is it getting cosmic ray? They mentioned ablation. Is that the mechanism that's converting then? It's changing its
no,
albedo, or is that
no, no.
going through the
So
outgassing?
the cosmic rays are changing hydrogen to changing water to hydrogen and oxygen,
Yes.
basically dissociating the water molecules. That happens over the millions of years of interstellar travel of this object. That's
Mm-hmm.
what makes it, in their paper, makes it different from comets that belong to the solar system, because they argue the comets in the solar system are often protected from cosmic rays by the solar wind. That by itself is not a good argument, because most of the long period comets come to us from the Oort cloud, which is
Right.
outside the
Yeah.
protection region by the solar wind. The solar wind is being stopped at 100 times the Earth-Sun separation. That's the heliosphere. And
Yeah.
beyond that, nothing protects solar system ices from cosmic rays. So in fact, when we look at long period comets that
We
come
should
to
see
us
it.
from the Oort cloud, we should have seen it. We haven't seen it. All the comets that we had seen had a coma. That's how they define. You go to all the classic definitions. Nevertheless, they define a dark comet as one that was exposed to cosmic rays for a long time. And I would say most of the long period comets were experienced the same cosmic rays as Oumuamua did. So why? And the second point is we had seen an object from interstellar space that was just like a familiar comet. It was discovered in 2019 by Gennady Borisov.
Yeah. Mm-hmm.
And the fact that we saw that comet Borisov means that you can't argue that you take a regular comet and convert it to an invisible comet when it's exposed to interstellar cosmic rays, because here is Borisov.
Right.
It looks like a comet. So why is Borisov different from this one? And the last point I would make is, in a way, defining an oxymoron, a dark comet, is similar to me to the newspeak that was mentioned in George Orwell's book 1984, where the party's slogan was "War is peace, ignorance is strength." Statements that are contradictory, and saying a dark comet is a self-contradictory. But at any event, they make this point that the interstellar comets are being affected by cosmic rays, and that's why. And the point is, they just forgot one thing. And as their paper appeared on Thursday in Nature, and the same day we submitted a paper to the Astrophysical Journal Letters explaining that the energy conservation equation was not properly treated. Basically, the idea is you have sunlight hitting the surface. There is radiation from the surface. That's one cooling term.
Yeah.
But another cooling term is you need to invest energy in dislodging the hydrogen atoms from the lattice. That is another energy loss that you need to include. And if you increase the temperature, this energy loss goes exponentially, because the higher the temperature is, the easier it is to dislodge hydrogen atoms. So once you start raising the temperature up to 100 degrees Kelvin, you get a huge evaporation rate of the hydrogen from the water. And that carries all the energy that comes in. And then the temperature would go down. So in order to calculate the temperature, you need to balance the heat input from sunlight with the energy losses from radiation and evaporation of hydrogen. Really trivial. They forgot to include the cooling as a result of the energy needed to be invested in evaporating the hydrogen, just like I talked before about forgetting to feed your family if you're getting a salary and claiming that will be sufficient.
Right. So
So,
I'm showing the paper that you submitted with, is it TM Hong? That I'm showing on the screen now. I'm sharing the paper that you submitted. So
right,
I wanted to also ask you one other thing, which is that the it's not that it's new to suggest that there's some sort of iceberg type object, right? So how
no,
does this differ from, I guess there's paper from McKelly et al. In 2018. And by the
right.
way, I mean, you didn't discover Oumuamua, right?
No.
And there were others that
I'm a
participated.
theoretical astrophysicist, and
Right.
I'm just to explain the reality reported by observers. So there was a Nature paper back in 2018 in June, and that's what led me to the suggestion that Oumuamua is really weird, and perhaps not natural, perhaps manufactured by an extraterrestrial technological civilization. That's that's the straw that broke the camel's back for me. Too
Right.
many anomalies. But the one that Marco Micheli, reported in Nature was that there is this non-gravitational acceleration pushing it without a cometary tail. And the question was, what is pushing it? And I suggested that it's sunlight because the acceleration, the excess push, declined inversely with distance squared from the sun. That was a good description of it in a smooth fashion. And I said, well, that's exactly how you expect sunlight to push a very thin object. And moreover, there was no jitter in the spin of the object, and no change, no evolution in the spin, the way you see it for comets. And you need, if it were a comet, irrespective of whether the evaporating gas was visible or not, you had to evaporate about 10%, a significant fraction of the mass of the object. So it would be really difficult to hide it. And the Spitzer Space Telescope looked very deeply around that region and couldn't find any carbon-based molecules. Whenever we have water evaporating from the surface of a comet, there is also dust and there is carbon-based molecules. So you can't just argue, oh, this one is very different. In fact, one of the authors of this paper, Daryl Seligman, he wrote a review paper about Oumuamua, and he wrote an email to me last summer saying, I just finished a review paper in a very prestigious journal about the comet Oumuamua. And I replied, what do you mean by the comet Oumuamua? We both know there was no cometary tail. How can you call it a comet? And
Right.
he said, well, I have this theory that it had a cometary tail when we didn't look at it. And when we looked at it, it didn't have a cometary tail. And so I said, well,
That's what Einstein said about the moon.
I
Is it
said,
really there when
this
you
is,
don't look at it?
I mean, this is just like going to the zoo and looking at an elephant and arguing that the elephant is actually a generic zebra that shows its stripes when we look away from it. And how can that be a mainstream view in overviewing an object that looks weird? You can't just say it's a comet when it's not a comet. Sometimes I feel like the child in Hans Christian Andersen's tale, that said the emperor has no claws. Here, the emperor is Oumuamua, and I say it has no cometary tail. And everyone else, like the adults looking at the parade, say, "Oh yeah, it's a comet with invisible claws. It's a dark comet." To me, it's an oxymoron. I'm
Well,
just following
one of my listeners is asking an interesting question, Avi. Could you both be right? He's asking, could the object be an iceberg sort of towed by an extraterrestrial? In other words, could an extraterrestrial object be affiliated with this, maybe for its source of water or something? What do you think about that idea?
Well, it's possible. It's possible. I don't know. So this object was the size of a football field, and the argument, if indeed it was pushed by reflecting sunlight, it had to be very thin, sort of like a sail or a very thin object. And actually, the same telescope in Hawaii observed another object that exhibited similar qualities in September 2020. It was given the name 2020 SO. And it was realized a few weeks later that this was a rocket booster that NASA launched in 1966. And it had thin walls made of stainless steel. And that's why there was no cometary tail. And because the walls were thin, it was pushed by reflecting sunlight. So you can imagine, of course, something like a light sail that has a payload attached to it, perhaps. But my point is, there is no evidence for the payload. Okay, what we
Right.
see is we don't have an image of the object. It would have been nice to have one, but given the data that we have, one simple explanation is that it's being pushed by sunlight. And you may ask, where would such an object come from? And it could be just space trash. I wrote a paper that was published 2 weeks ago, actually, talking about Dyson spheres. So
Mhm.
Freeman Dyson, 60 years ago, suggested the idea that a very advanced technological civilization might build a megastructure around its host
Yeah, he
star.
was my first guest on the podcast, Avi.
Oh, really?
Yep.
Really? Anyway, I always admired him. I
Yeah,
met him personally for many years at the Princeton, the Institute for Advanced Study, where I was a postdoc. That's
that's
where I
right.
learned astrophysics. Anyway, so his suggestion was that an advanced civilization will try to harvest much more energy from its host star than we do. Even with our plans for clean energy, at best we can harvest the energy intercepting with the Earth. But he was thinking, surrounding the star with some kind of a sphere, and it could be made of tiles that are basically light sails.
Yep.
That's what Robert Forward suggested as a variant on Dyson's idea. Basically, having tiles such that the radiation pressure outwards is balanced by gravity inwards, so you have those hovering above the stars. And so, at any event, if the civilization is using a Dyson sphere for a while, eventually it might migrate away, especially when the star evolves. And if it leaves the structure behind, the structure could be torn apart by impacts of asteroids, or actually, if it's made of tiles of solar sails, when the star evolves, when the sun will brighten up, it will push away because for the same mass, it will
Mm.
have much higher luminosity. So it will push away all these tiles and they can become interstellar objects. And one of them may have been Oumuamua. So it could be pieces of a broken Dyson sphere. So that's an example for space trash that could lead to very thin objects that pollute space, and every now
But
and
would
then
they
you see.
accelerate? Would that type of space trash accelerate? Unusually.
Well, it will because it's thin. All you need for it to exhibit excess push away from the sun is for it to be thin, so that its area per unit mass will be high. And that's what the 2020 SO, which was the rocket booster from NASA,
Yeah.
that's what it was, and it showed that phenomena. So that's what I was suggesting, that Oumuamua was thin and therefore pushed away. We don't know what the origin of it and what was it designed for. I should another footnote. I should mention that there was a paper that I've written with the director of AARO at the Pentagon. There is an organization collecting all the data about unidentified aerial phenomena,
Hmm.
and we had a draft together with him. His name is Sean Kirkpatrick, which got a lot of attention just because the Pentagon is collaborating with a scientist from an Ivy League university. At any event, in that paper, which was not yet submitted because it's under review, um, um, in that paper, we mentioned in the introduction the possibility that you can have a mothership that releases a lot of small probes. And the reason I came across this idea is because Oumuamua shared the same distance of closest approach and the same speed as an interstellar meteor that was discovered 7 months before it in March 2017. And it was detected by the US government and put in the meteor catalog. And together with my student, Amir Siraj, we identified it as moving too fast to be bound to the sun. So we identified it as an interstellar meteor of very high material strength because it burned up in the lower atmosphere of the Earth. This was the second interstellar meteor. We discovered another one from 2014. But what was special about the 2017 one is that it shared the same distance at closest approach to the sun and the same speed at that distance as Oumuamua did. And so I thought to myself, oh, let's check the orbit because maybe it was released. Maybe it's a fragment, either naturally broken off, a piece broken off Oumuamua, or it was purposely released as like dandelion seeds. Like if you
Hmm.
have a large mothership releasing probes into the habitable zone. But it turns out that when you map the orbit, they couldn't have come from the same place. And But that led me to suggest a possible scenario. Of course, the purpose of any extraterrestrial technological gadget depends on what the senders wanted to use it for, or it could be just space trash. When you go to the ocean, you find a lot of plastic trash, and it indicates that there is a technological civilization out there. In fact, the mass of this trash will exceed the mass of fish in the oceans by 2050 if we don't stop throwing trash into the oceans.
But that a human generated trash, not extraterrestrial trash.
No,
So,
this one is human. But if you're asking if there is an extraterrestrial equipment in the ocean, that's what we're going to find out, and we can talk
right.
about it more. That's the first interstellar meteor. We will try to go there to the explosion site of that meteor and find the relics from it in order to analyze their composition and figure out whether it was a spacecraft actually, because it had material strength tougher than iron. We can talk about it more.
Yeah, we'll talk about it. I'm showing that paper on the screen, your paper from August 2022 with Amir and Tim. But when you talk about the confidence interval, and apologies, we're talking with Avi Loeb, professor of astronomy at Harvard University. Brian Keating, not feeling 100% great today, but I could not miss my opportunity to share with you, my beloved audience, this conversation with a renowned friend and thinker. You talk about the probability of it not being extraterrestrial, extra solar, and you say it's 99.999, 59%. Is there really no, 1 in a million like these objects? Could they not be scattered from the Oort cloud and some violent collisions from some interactions from local stellar systems and so forth? Is it really true that we have? I mean, I have these meteorites here, which I give away to my audience when they sign up for my mailing list at briankeating.com/list. I'll put that up on the screen. So if you have a .edu address, you win one of these chunks of. This looks like Oumuamua, doesn't it, Avi? This will look right.
Well, it's a miniaturized version because Oumuamua was the size of a football field.
That's right. I couldn't fit that here. Our budget at UCSD is not as large as Harvard. But is it really so hard to get an object from another solar system into our solar system? Can you explain that?
So let's talk about the first interstellar meteor, which was the first object from outside the solar system ever discovered by humans. And it was detected by the US government, as you mentioned, in 2014, January 8th. And they just cataloged it. NASA put it in a catalog of meteors. So the US government monitors the atmosphere, for ballistic missiles as a national security matter. And every now and then they see an object coming from out there and colliding with Earth. It's a meteor, it's a rock, usually from the solar system. In fact, every year there is a rock the size of a person colliding with Earth every year that releases as much energy as the Hiroshima atomic bomb. Wow. So we get an atomic explosion every year. We don't hear about it, but because it happens 30 kilometers above the ocean surface, most likely above the ocean, because the oceans cover most of the Earth, 70%. But it doesn't cause much damage at such an elevation. And we just don't hear about it, but the US government knows about it. And they basically catalog meteors that they see from the fireball that is created as a result of the friction of this object with the air. So they do catalog them, and we found this meteor from 2014 that moved too fast to be bound to the sun. And in fact, we calculated how fast it was moving outside the solar system. Before it entered the solar system, it was moving at more than 60 kilometers per second, which is faster than 95% of all the stars in the vicinity of the sun. Wow. So it was moving so fast outside the solar system that you couldn't get it to move that fast as a result of an interaction with an Oort cloud object, or it wasn't even moving close to any of the planets in the solar system. And a passage of another star at a large separation would not give it much of a kick. In order to get a kick of, order 60 kilometers per second, it really needs to interact with a star even closer than the separation of the Earth from the sun, maybe by a factor of 4 or so. So it really needs to pass extremely close to a star, which is a very unlikely event. So it was moving too fast to be bound to the sun and even too fast to be associated with any of the nearby stars, 95% of all stars. And the question is, what was it? And of course, when we submitted our paper for publication in 2019 saying this is the first interstellar object, it predated the Oumuamua by almost 4 years, the referees in the Astrophysical Journal rejected the paper.
Huh.
They said, we don't believe the US government. And I thought to myself, how can that be the case? If they're trying to figure out whether a ballistic missile will hit Boston or New York City, they must have very good sensors. They can't get it wrong. And I basically reached out to people in over the national security fence, and eventually it was a person in the White House that mediated the release of information, and there was a letter sent to NASA by the US Space Command under the Department of Defense, stating at the 99.999% that the error bars were small enough that this object definitely at the 99.999% came from outside the solar system. That's it. That
Yeah.
it must have been, the error budget was extremely small. And then our paper was accepted for publication. And the US government also released the light curve of the fireball, and moreover, additional data on this meteor. And that allowed us to calculate that it actually exploded 10 kilometers above the ocean surface. And that's very low in the atmosphere compared to the 30 kilometers I was mentioning before. So that meant that there was an extremely high stress exerted on the surface of the object because it moved very fast, and it was also it experienced a density of air that is quite high at the bottom of the atmosphere. And we calculated that the material strength of this object must have been 10 times higher than any other object in the catalog of 273 of them that the government compiled. So why would the first interstellar meteor be the toughest of all the space rocks ever detected by these sensors? And there are two possibilities. Either it originated from a system very different than the solar system. So even in the solar system, the toughest meteors are made of iron. They are called iron meteorites.
Yep, that's what you'll get if you sign up for my mailing list. Yep.
Yeah, they're the toughest, and this one was 10 times tougher in material strength. The question is, what was it made of? And of course, it could have arrived from some natural source, like, for example, an exploding star or two neutron stars colliding, something that we've never imagined producing interstellar objects. Or it may be an artificial alloy made of stainless steel, once again, like a spacecraft. And the only way to figure out is not to argue about it on Twitter, the way some people do. I don't have any account on social media, as I said, and I don't want to argue. I just follow the scientific method. I just want to go there and collect fragments and then examine their composition. It's straightforward. That's what a kid would do. If you have a question, you go and check it, test it. And so I said, we want to go there after the paper was accepted for publication. And then soon afterwards, a person from the general public came forward and said, on a Zoom meeting, on a Zoom call, he said, you have it, $1.5 million necessary to fund the expedition. Here it is. Go ahead.
Wow.
Okay. So I didn't do any fundraising, and this person will come with us actually on the expedition. His name is Charles Hoskinson. And he was very generous. And that's the way I raised funding also for the Galileo project, separate from the expedition. I got a few $1 million this way.
And you know what's nice? You're too sneaked, you're too modest, Avi. But I'll have to toot your horn a little bit here. So, one thing that strikes me about the research that you do and the approach to the scientific method that you endeavor to uphold, and why I like talking to you so much, is that you're doing stuff that is incredibly intellectually stimulating. You're trying to do it with integrity. You're also trying to do it for the benefit of the public. And I think a lot of what we do is kind of cloistered away. And part of the reason I love doing this YouTube channel, aside from the fact I get to talk to the most brilliant people on earth, including, this week alone, I'm going to have a conversation with the new superconductor. You think it's controversial, Avi, talking about Oumuamua? Imagine you announce a room temperature superconductor. So I'm talking to some of the critics of that paper as well. So anyway, but the last thing is that you do it for the benefit of the public, meaning that these endeavors are meant to maybe reduce the cost to the public of things like a huge NASA study, which is being led by our mutual friend David Spergel, to study the properties of extraterrestrial data, perhaps, or unidentified aerial phenomena more precisely.
Right.
But this mission, you point out in this paper from last year, is about 1% or maybe less of the Bennu mission, right? So
Yeah.
going to
Ex-
Earth, it's like Elon Musk, who is so ingenious, but he wants to go to Mars and live out his days on Mars. And our mutual friend Martin Rees says, I hope you don't die on impact on Mars, to Elon. But isn't it much more likely to find a habitable zone on Earth than to go to Mars? As cool as that would be, and I'm sure
oh
I
yeah.
would love to take the 20,000th ride to Mars, but you're doing this for the benefit of the public. This is
Yeah,
not a
that's
public taxpayers, right? This is not some
right.
international team. This is you guys and some speedos going down to New Guinea. So yeah, I want to commend you for that.
Thank you. I mean, I don't see myself, even though I'm a member of the Ivy League, I don't see myself very different than any common person, any person on the street, because I grew up on a farm. I used to collect eggs every afternoon. I was connected to nature. I'm not trying to impress people. If I see the public interested in this subject and the government is interested in this subject, then how can the scientific community shy away from it? How can it be arguing that it's too risky, it will be a waste of taxpayers' money when the taxpayers want it?
Right.
And so at the same time, we are spending billions of dollars in the search for dark matter. The Large Hadron Collider didn't find supersymmetry, and that's not considered an extraordinary claim. But that something like us exists or existed around a planet like the Earth, moving around a star like the sun, is considered an extraordinary claim. And I say that is arrogant. It's as arrogant as saying, I don't care about the public opinion. There are more than 60% of American citizens that believe
Yeah.
in extraterrestrial life. And
And
I would
and
say,
yeah, go ahead.
this is more than the number of people believing in God. And I would also argue that, most of the stars from billions of years before the sun. So we should just look out and check if there are any packages in our mailbox. And in the past, I get hostility also from the SETI community, which is very surprising to me, because what I'm doing is looking for techno signatures, which is what they're doing, but in a different way. So they're
Right.
looking for radio signals for 70 years, haven't found anything. It's just like waiting for a phone call at home. And there may not be anyone calling you at the time that you're waiting for it. I say, let's look at our mailbox, at our backyard, and see if there are any packages that arrive. Because even if the senders are not alive anymore, even if their star burnt up their planet, it's possible the packages arrive to us and we can learn about them.
Yeah.
And
And I also the
either
point.
yeah.
Yeah.
So
As you
yeah.
said last time you were on with Gary Nolan, we'll have a link to that on the show. You've discussed this many times, but you had a great line. You said the sky is not classified,
It's not
and
classified.
the ocean's not classified. Well, parts of the ocean are classified, but the ocean's not
No,
classified.
I should also say that, when you go to your backyard, what my colleagues are doing with respect to Oumuamua is saying, oh, we've been to our backyard, we know that it's full of rocks. And I say, well, if an object arrived to our backyard, we all agree that it arrived from outside of our backyard. That's what an interstellar object is. Maybe it's a tennis ball that was thrown by a neighbor. Why would you assume that all the objects that come from the street are rocks of the type that you find in your backyard? And, we know already that most of the matter in the universe is not what we find in our solar system. Most of the matter is dark. We don't know what it's made of. We call it dark matter. We learned already that the solar system is not representative of the universe. So why would we argue that any interstellar object must be a rock, even if it looks different than all the rocks we had seen in the solar system? That's just common sense. And what I find is that common sense is not common. So on the one hand, I see people from academia attacking a very simple, approach that uses the scientific method, basically trying to collect evidence. They have a problem with that. They say extraordinary claims require extraordinary evidence. And how would you get evidence if you're not searching? That's my point. I say extraordinary evidence requires extraordinary funding. And what happens is that they don't fund any research in that direction, and therefore they say there is no evidence. It's as if you would say the claim that the dark matter is the lightest supersymmetric particle is extraordinary, and we don't have evidence for that, so we should not explore it. That's not what the mainstream of physics did. It said this is a statement worth putting billions of dollars to testing.
Right.
And then they didn't find it. And nobody says that was a waste of money. Why? Because that's the way science is done. At the frontiers, you're exploring the unknown. And you can't just say that the lightest supersymmetric particle is an extraordinary claim that requires extraordinary evidence, because to find the evidence, you need to put in billions of dollars. So that's what's happening in the context of technological objects from extraterrestrial civilizations, that nobody is willing to put the money, except when I come forward with a research plan, then wealthy individuals come forward and say, here is the money, because they see, that this is the way, the path for us to expand our scientific knowledge. And it's just straightforward. I don't see why people.
No, it's true. And one thing I love is that you're not even shy to kind of stimulate discussion. I don't think you pick fights. I think you stimulate discussion, even with colleagues down the hall at Harvard. And you and I talked about this, I think the first or second time you're on the podcast, and you've been gracious enough to come on multiple times, but your friend Kamran Vafa, and he and I had conversations, and we can bring up stuff. And that's the way science should be done. Science isn't done by debates and by press releases. I can't help, because I do want to take a couple questions before my voice gives out for my audience. But before I do that, I'm going to ask you a question. You have your choice. Hashem, God, he tells you, Avi, pick one, Oumuamua or this meteorite. Which one would you rather have be actual proof or evidence that alien civilizations, technological civilizations exist?
Well, obviously the meteorite, because I can go there and study it. You see, Oumuamua is not around anymore. If I had a close-up photograph of Oumuamua,
that's what I mean. Yeah, so a close-up photograph, or that proves it's actual, like a spaceship, or that the meteorite is just space junk from another.
I'm a practical person. I don't really imagine. If we had an opportunity to go to Oumuamua, obviously I'll do that. But right now, the best way to proceed is to check what this meteor was like. Of course, we can find more objects like Oumuamua. We have a dating app, which is called the Vera Rubin Observatory, that will have a survey of the sky with 3.2 billion pixel camera in a year or so, and it will survey the southern sky every 4 days, and presumably we'll find more objects like Oumuamua, so we can get close to them, observe them with the Webb telescope, which is about 1 million miles away from Earth. So we will see the object from two directions, from telescopes on Earth and from the Webb telescope. And that would allow us to pin down the trajectory in 3 dimensions very precisely and figure out whether there is some propulsion or whether it's just the trajectory is shaped just by the sun's gravity. That would be a great benefit. So that there are lots of things to do in the future. And, I was asked by a podcaster just a few days ago in a podcast called Unheard, Unherd.
We can't advertise competitors' podcasts here, Avi. Do not.
I'm just advertising one question. The question was, we hear from many of your colleagues that they are 100% sure that Oumuamua was not an extraterrestrial technological relic. And I said, well, that's a reflection on them, not on Oumuamua, because there were people during the days of Galileo also 100% sure that the sun moves around the Earth. The point is, when you have incomplete data, you cannot be sure. Only believers are 100% sure. Scientists with partial data are never sure. So if you want to follow the scientific method, all you say is, I want better data in order to figure it out of curiosity, being like a child. If we don't ask those questions, we basically broadcast worldwide that we lost our childhood curiosity.
The problem is sometimes they're too childish. Sometimes they're too childlike. They want to take their toys and go home, and they want to be jealous and petty. But so Avi, we have a few minutes left. I've got a ton of questions, 700 questions here.
Go ahead.
I'll only ask you. We'll do a rapid fire. Rock Esty is asking, is it significant that of all the planets in our solar system, that both Oumuamua and this meteorite came to the Earth instead of, say, Jupiter.
Oh no, okay, it depends on the trajectory. So if you assume that it came on a random trajectory, there should be an object like it every year coming into the orbit of the Earth around the sun. So it's really common. However, you can reduce the number of objects by a factor of 10 to the 10 billion or so if you imagine that they were targeting the habitable zone. So if they were sent into the habitable region where the Earth moves around the sun, then there are many fewer by 10 billion. And we don't know. So we just need better statistics. And hopefully the Vera Rubin Observatory will give us more examples.
Hmm. So, someone's asking about JWST. Is anything JWST can do with regard to searching for these objects or similar
Not to
objects?
search, because the Webb telescope has a very small field of view for the 5 arc minutes,
Yeah.
about a tenth of a degree, and so it's a very small view. And these objects, you need to look at the entire sky in order to find one of them. And so in combination with the Vera Rubin Observatory that will survey the sky, that could alert the Webb telescope to an existing object. And then it's just like having two eyes, you can gauge distance much better. The reason we
Yes.
have two eyes is so that we can have three-dimensional uh, calibration of the threat that is in front of us that allows us to survive. So in the same way, Webb telescope and Earth-based telescope could figure the distance and very precisely to an object like
Oh,
Oumuamua.
great. Okay, next question. Tolip asks, this change in speed of Oumuamua was small compared to a typical comet moving in an elliptical orbit. I guess my question is, do we see comets that just move? I mean, that we know that are comets that have a cometary tail. Do they ever exhibit strange accelerations comparable to their
Yeah,
elliptical orbit
definitely.
speeds?
This is coming from the rocket effect. That when it's the same effect that is pushing rockets or jet planes. Basically, airplanes, and I once did a calculation on a fly, they throw back material so that it pushes the jet plane forward. That's basically what happens. And the same is true about rockets. And you need to carry the fuel with you. And a comet is exactly the same thing. It has water ice on the surface. It evaporates as a result of the warming by sunlight, and then it pushes the comet in away from the sun. And yes, we do see that for small enough. So the force is proportional to the surface area of the comet, and then the acceleration is the force divided by the mass. So the mass goes like the volume of the comet, and therefore the area to volume ratio dictates how much it's accelerated. So uh, in other words, the acceleration is bigger for smaller objects. It's inversely proportional to the size of the comet. So for small comets, you can get much more acceleration, and it's noticeable. For very
Hmm.
big cores, you don't get that. And so that is observed for comets, and that's the way they behave. And Oumuamua exhibited the same kind of an acceleration, except there was no cometary tail.
Hmm. When we look at things, someone's asking, Brian Kelly is a friend of the show, is asking about the Pioneer space anomaly, things like that. Are those, I guess my question would be, we know cosmic rays exist and we know that, these light sails can exist. Do we have any evidence that light sails could be damaged or, affected by, in other words, could there be sort of a hybrid solution? Light sail, cosmic rays, could these interact in some way that could
Yeah.
degrade the performance or change trajectory and do such things?
Yeah, we actually in the original paper suggesting that it's a very thin object, Oumuamua, we actually made an estimate what is the impact of either cosmic rays or interstellar particles, dust particles, gas particles on it, and we concluded that it's quite minimal. I mean, it will not destroy the object simply because the interstellar medium is so dilute. I mean, obviously, you can have holes in the sail as a result of dust particles passing through, but it will not destroy the entire sail simply because the medium is very rarefied out there.
That's right. So, Avi, I want to just conclude by, well, asking you if you had to do what we call a steel man, if you had to give your best reproduction of the criticism against you, what do you think is the best critique of the Oumuamua as extraterrestrial technology? what do you think is the best, in your estimation, of all the critiques?
Yeah. So I would argue that, well, first of all, this paper in Nature that appeared a few days ago in the abstract says explicitly that past explanations of the non-gravitational acceleration in the form of a hydrogen iceberg, nitrogen iceberg, dust bunny are not valid. The paper admits that. And now we showed also that what the paper suggests, the hydrogen water iceberg, is also not valid because of energy conservation. So all of these have issues, all of the explanations. And if you wanted to explain what was observed, I would argue maybe the data was wrong. The observation reported results that are not valid, in the sense that when people analyze the trajectory, they forgot to compensate for some error in the measurement. So if I had to guess, my guess would be that the original Nature paper, if you don't want to admit that Oumuamua was a very thin object, that the original Nature paper from 2018 by Micheli was wrong. Simply, the data that they analyzed was miscalculated. There was something off, and they inferred a non-gravitational acceleration, but it wasn't. In reality, it wasn't there. That would be the simplest way to resolve it without any commentary tail.
Very good. Well, Avi, I want to thank you so much. Apologize for my my voice, but as I said, I couldn't miss it for the world to have a chance, or out of this world to have a chance to chat with you. You're always such a gracious guest and one of the favorites of my audience, which is growing thanks to having guests like you.